Hello and welcome back in our continued journey of mastering algebra, and we are still at the day 0, day 1 kind of territory. We are still working with fundamentals, making sure that we are very comfortable with the basic operations, because as we have seen over and over again in module after module, complicated things are made up of small, very many small little things, right? So we want to make sure that we master the small. And even though I'm calling it day 0, day 1 territory, even as we move into later chapters like quadratic equation, we'll see the same ideas repeating over and over again. Just that today I'll be starting with very easy examples. So we have looked at algebra as input output functions in the very first session. Then we looked at some graphing operations, visualizing the input output relationship, understanding the line equation, understanding terms like slope, just plotting it on the graph as such. And then we also learned how to play with polynomials, how to multiply terms together. So by now we should know how to multiply these two terms together, right? So we'll start the journey from that point. But our today's agenda is the opposite of what we learned in the previous session. In the previous session, we were multiplying to get one expression. Here an expression would be given to us and we would be asked to break it down, to factorize it, right? And what do I mean by factors? Say if I give you a number 10 and I say give me factors of 10, you will say 1, 2, 5, 10 are factors of 10. That means numbers which divide 10. So similarly, when you say factorize an expression, you're looking at breaking it down into smaller components as such. For example, this is already the factorized form. Let's start with multiplying this, and I'm assuming everybody already knows how to do so. So x into x is going to give me an x square. X into 5 is going to give me a 5x. 3 into x is going to give me a 3x, and a 3 into 5 is going to give me a 15. If I simplify it further, x square plus 8x plus 15. Now, this is what we learned in the previous session. Now our agenda is somebody will give me an expression looking like this, and he will say try and convert this into this form, the factorized form, right? And even with this basic multiplication, I can start observing a couple of things. If I look at this final constant term, this 15 is 3 into 5, right? And if I look at this 8, it is 3 plus 5. So there is a product in the last term and the sum is involved in the coefficient of x. Take your time, change these numbers a couple of times, make sure that idea is very, very clear to you. If I go for the general form, if I say, okay, instead of 3 and 5, let me write x plus a into x plus b, and I get x square plus x into a plus b plus a into b. So the product, the sum, and this is the expansion, right? So this visualization, this understanding is very important, because once I get an expression like this, when I remember that okay, the last one is the product, the middle term is the sum, the coefficient of x is the sum, it will give me a couple of starting points to start working with the expression, right? In fact, let me start with a even more basic example. All the examples or the problems that I am discussing in this video, they can be found in the document attached below. Please try them out by yourself. In fact, if you can manage them very easily, maybe you can skip this session. Even if you are good at the idea, try and do those problems orally. If you're good at maths and you already know these kind of things, just try out the problems orally and make sure that the engine is warmed up, right? So a very simple example, 5xy. This is that absolute 0 day, 0 level idea that I am talking about, taking things common and multiplying them using a bracket, right? So for example, from this expression, and I will go very, very slowly, can I take the 5 common? Yes, I can. I'll be left with an xy, and inside I'll be left with a 2x. So this process is what we want to master. This is basic factorization. This kind of game we have also seen in other topics like number system already, or we will see it again in topics like number system. So most people should be familiar with this idea. And again, in the next step, I can take the x common, right? I can take the x out. So 5x into y plus 2. Always check it, multiply it back. 5x into y will give you a 5xy, 5x into 2 will give you a 10x, right? So this was the original expression and this is the factorized form. And that tells me, for example, that 5x is a factor of this expression. Y plus 2 is a factor of this expression. That means if you take this expression and divide it by y plus 2, the remainder will be 0. If you, this expression and this expression are the same, so you take this expression and divide it by y plus 2, the y plus 2 will get cancelled and 5x will be your quotient. So your basic division process is just a quick reminder, the divisor is equal to dividend into quotient plus remainder. Learn it by an example. 17 is the divisor, the 17, so 17 is the dividend, let's say 5 is the divider, 5 into 3 and the remainder is 2. So 5 3s are 15 plus 2, 17, or if you want to look at it the way most people are familiar with, 17 is being divided by 5, 5 3s are 15 and then the remainder will be 2. So this is your basic division process and the same thing works here. So remember, if I say 5 into 3 and divided by 3 or a 15 divided by 3, this 3 gets cancelled. Whenever the divisor gets cancelled, it means that the remainder is 0 and whatever is left is the quotient. If this idea is unfamiliar to you, though the idea is very, very simple, I'm just clarifying it further that when you execute such a division process, what is the leftover? The leftover is the quotient, right? So this is what we mean by essentially the basic, the zero level process of factorization. And what do I mean by a factor and our basic ideas of division as such. So question number 2, question number 3, question number 4 I will leave for you to try out. Let me try question number 5. It says 2xy plus 2y plus 3x plus 3. Okay, so again the game is very simple. Let me look at what is common between expressions and let me try and eliminate them. I see between this term and this term 2 as well as y, 2y is common. That means I can take that 2y outside of the bracket and I'll be left with a single x. If you're a beginner, always just multiply this and you will see, okay, you got to this point, and after a couple of rounds your brain will automatically pick up the process. So 2y into x gives me a 2xy and I want another 2y which simply means a 1. 2y into 1 will give you a 2y. Let me play with this. What is common between these two terms? I can take the 3 common and I am left with 3 into x, 3x, and I am left with a x plus 1. Oh wow. Is there something common between this term and this term? Yes, the x plus 1 is common. So I will take the x plus 1 common and inside I'll be left with a 2y because this into this will give you this term and inside I'll be left with a 3. So this is the same as this and x plus 1 and 2y plus 3 are factors of this. That means if I take this expression and I say, okay, divide this by x plus 1, you know the remainder is going to be 0. And what is the quotient going to be? If you divide it by x plus 1, this will get cancelled and this will be your quotient in the process. Again, if any of this is confusing, you just need to write down the term in your notebook and say, okay, I need to learn this further, or learn by yourself only. What do I mean by quotient? What do I mean by remainder? When we do something like this, 21 by 3, and we say, okay, this is 7. What is this 7? This 7 is the quotient in the story. When things are getting cancelled as casually as it appears on the surface, that means the remainder is 0. So we do this, everyone knows how to do this, but they might not observe the details and nitty-gritties that, okay, remainder is 0 and this term that you are left with is the quotient as such. So again, a simple enough factorization. So now we are going towards factorizing quadratic equations. In fact, as I said in the beginning, this is a day 0 session, but even later when you move into a quadratic equation chapter or identities chapter, you will see that the same ideas are repeating over and over again, right? So this is the expression and I want to factorize this. some of you might have figured this out very quickly, that this is nothing but x plus 4 whole square, right? But how do I think about it? I think of the product. I know this term is a product of what? In my expression like this, if I take this as my benchmark, as my standard form, this is the product of a and b, and this is the sum of a and b, right? Because I expanded this to x square plus x into a plus b and plus ab. So this is ab, and this coefficient of x is a plus b. So this is my starting point of the beginning of the journey. So I'm thinking, okay, 16 is the product of what two numbers? Okay, it could be 1 into 16, but 1 into 16, the sum will be 17, so this is not going to work for me. It could be 2 into 8, but if the product is 2 into 8, the sum should have been 10, so this is not also working for me. Product could be 4 into 4, and 4 plus 4 gives you 8. So A as well as B both are 4, so that means this expression is the same as x plus 4 into x plus 4, or then you can simplify this as x plus 4 whole square, which is nothing. You can again expand it using your other identity a plus b, or let me not use a and b because they appear here. Let's say p plus q whole square, your standard the most zero level identity number 1 as I call it, the whole square. A plus b, p plus q whole square means p square plus q square plus 2pq, right? So this and this are the same, and all of them are coming from where? They're coming from being able to multiply two polynomials. So if you know how to multiply, you don't even need to memorize this, but they will appear so many number of times that it is worth while just putting them into your memory banks, or they will get memorized anyway, right? So a couple of things getting started, that we understand that this is the expression, this is the product, this is the sum, this is also the beginning of the quadratic equation already. Not getting into the details right now, but this is a quadratic equation and we've already factorized it. And later, half an hour later, 45 minutes later, we'll also learn, once we get the factorized form, we also figure out where the expression is going to be equal to 0, or we get into roots and solutions. All very easy ideas, right? But notice the same idea being presented in different formats. In fact, even before starting with other problems, just play with the data yourself, right? Build your own story. So you say x plus 5, and this time I go for a minus 3 because I've already seen the x plus a, x plus b, that is my standard scenario. Let me play with this. X into x is going to give me x square. Notice I'm not even using the things that I've learned. I'm going for my basic multiplication. X into minus 3 is going to give me minus 3x. 5 into x is going to give me 5x. 5 into minus 3 is going to give me minus 15. So once I sort this out, I get x square plus 2x and minus 15. So notice, if one of them is positive and the other one is negative, the final product turns out to be negative. Whether this is positive or negative depends on which one is bigger. So for example, what if I change the story to x minus 5? And what are we doing right now? We are just playing, so that we play with this so many number of times that the basic equation at least is very familiar to us. It's on our fingertips, right? So if I change the story so, and I build it again, I will get an x square. I'll get a x into 3, which is a plus 3x. And I'll get a minus 5 into x, which is a minus 5x, and a minus 5 into plus 3, which will give me a minus 15. So this minus 15 is the same, but notice this time it will become x square minus 2x and minus 15. Right? The point being that try it out with different scenarios so that nothing is unfamiliar to you. Half the time the problem is just, okay, I've never seen something like this. So, and extrapolating from one idea, right? What if both of them become negative? X square, x into x is x square, x into minus 3 will give me minus 3x, minus 5 into x will give me minus 5x. Now I'm taking a shortcut, not even a shortcut, I'm just not writing the step down, right? That's how your muscles get developed. So minus 5 and minus 3 gives me a minus 8x. and minus 5 into plus 3, minus 5 into minus 3 gives you a plus 15. So get familiar with the idea. What keeps changing? If you see a plus here, it means either both of them are positive or both of them are negative. If you see a negative here, that means one of them is positive, one of them is negative. If you see a negative here with a negative sign with a coefficient of x also, then you can start memorizing all of this, but you don't need to if you play with this basic scenarios a few times basically, right? And then again your common sense, your galactic intelligence will take over and it will sort out the data for you. You would not have to think about it. So I hope all of this is making sense. With the theme of playing only and just preparing my own journey, I can create an expression like this: 2x plus 3 into 2x plus 5. Right now, so what I've done, what is the change that I have created from my standard expression? Now the x also has a coefficient. But it doesn't matter because it's still the same story, and in fact I don't even need the story. I'm going to start with just multiplying. 2x into 2x gives you a 4x square. 2x into a 5 gives you a 10x. 3 into 2x gives you a 6x, and a 3 into 5 gives you a 15. So a lot of things are similar. This is still the product of these two, 15. It's positive because both of them are positive. And here you get, let me simplify it, you get a 16x. But if I look at the sum is only 5 and 3, 8. So how is it becoming 16? Because the x itself this time was 2x. So not only it is 8 into x, it is 8 into 2x. Therefore it is becoming a 16x, right? And it is still the same idea. If I have clarity in terms of how things are multiplied, again and again, after 5 more examples of trying it out, I should be able to figure out this kind of an expression. That means, let's say this was not given and this was your question. So you look at, okay, 15, what could be the numbers? But there is a 4x square. That means there must be a 2x here, right? So a couple of starting points in case the expression is not as simple as we have just been working with. That means even complicated expressions come from this kind of a story only. Disruptive of the process. What about this? This time I have not only, there is a coefficient of x, it is different for the different brackets as such, right? But again, just multiply once so that next time you see the resulted expression, you will know, okay, that could also be a story. That means you don't want to stick to a formula, we want to stick to the fundamental process, right? 2x into 3x is going to give me a 6x square. 2x into 4x is going to give me an 8x. 5 into 3x is going to give me a 15x. And 5 into 4 is going to give me a 20. So I still see that the product part is still the same, but rest everything I have to figure out things a little carefully, right? So this will become 6x square, and 8x plus 15x is going to give me 23x, and then you write your 20. So if somebody gave me an expression like this, it would be more complicated to factorize compared to what we have seen earlier. And I hope you see why, because 2x into 4 gives you an 8x and this gives you a 15x, this is 23x. If you add it up, 5 plus 4, 9. If you multiply, you get the 20, but if you add it up and you say 5 plus 4, 9, you're not getting that 9 into 2 or 9 into 3, something like that. That is not happening. So it might be slightly tricky. But again, what you would do with such an example is, again you will start with, okay, I know this is the product. So the product will be 1 and 20. This 6x square, again I'll have to think that it is not like a 4x square which is a perfect square. This 6 means it is made up of 1 into 6. So this 6 means it is either made up of 1 into 6, it could be a x here or a 6x here. Or it could be made up of a 2 or a 3 and a 3 or a 2 as such. And then you play with it a little bit and then you will soon come to this point. So yeah, this situation will be slightly more tricky compared to the standard one. But if I have some experience just by multiplying these kind of expressions together, I will know, okay, it's not as direct as the previous category, but I can still think about it. So this 20 is 5 or 4 or 10 into 2. And this 6 also is giving me a hint. It could be a 1 and a 6 or a 2 or 2 and a 3 or a 3 and a 2 as such. And how will I know which one is it? I will try out the expression and multiply them together and see whether I'm getting the result or not. That is my ultimate test anyway, right? So this is a little bit of a exploration that how you can create your own expressions. Still you are very clear with them. It's your exam, it's your life, your journey. So the teacher saying x plus a into x plus b and then the resultant is not enough. You have to say, okay, what happens when it is x plus a and x minus b? What happens when it is x minus a and x minus b? What happens when I change the coefficient of x, right? And that's how the process or the mathematical thinking process gets built, right? So I hope this made sense. Let's return to the questions. So this is what we want to factorize, and after the recent discussion this should be slightly easier rather than just facing it directly. Again, my starting points are still the same. I know this is the product, and if there is a 4y square, the only possible situation I can think of is a 2y or 2y into 2y as such, right? So I have a 9 here, and a 9 could be a 1 into 9, right? And I know this has to be a sum, so 9 plus 1, 10. Even if I forget about this story, 10 into nothing gives you 12, so that story is not going to. So that story is not going to work for me. Let me try some other numbers. So 3 into 3, 3 3s are 9, great. 3 plus 3, because I want the sum here in the second term, the middle term. Sum is going to be 6. But there is a 12 here, and where is that coming from? The 2 hiding with the y. So I understand that, okay, my roots, my factorized form is going to be 2y, and 2y is going to be 3 3. What is it going to be? It has to be negative 3. Why? Because the result is finally positive. That means both of them have to be negative, and I already know the numbers to be 3. Now again, just to be sure, just to have a doubt-free experience, because finally your brain has to see all of this with the high amounts of clarity. So 2y into 2y gives you a 4y square. 2y into minus 3y gives you a minus 6y. Minus 3 into 2y gives you a minus 6y, which is a minus 12y. And then and then finally minus 3 into minus 3 gives you a plus 9. So 2y minus 3 into 2y minus 3 or 2y minus 3 whole square is also something that you can rewrite it as. So I hope this makes sense. Not only these two terms, maybe now we're also playing with the coefficient of the square or what are the possibilities of that. We've already looked at the infinite possibility where it could be different altogether. This one was comparatively easier. Let's try this next one out. A square minus 2ab plus b square. Again, if you're not familiar with this identity, good time to explore it. A minus b whole square. Memory is great. Working out manually or multiplying it and then finding the result is even better. So a minus b into a minus b. A into a gives you an a square. A into minus b gives you a minus ab. Minus b into an a gives you a minus ab. And a minus b into a minus b gives you a plus b square. So same story, minor variations in the story. So instead of this expression, I can very quickly write a minus b whole square, and then there is a minus c square. Now for a second, because we are playing in the realms of symbols manipulation, right? So instead of this a minus b, can I put a gigantic P here? So this expression becomes p square minus c square. Again, do I have some familiarity with that? If I create this story, a plus b into a minus b. A into a gives you a square. A into minus b gives you minus ab. Plus b into a gives you a plus ab. Boom, this gets cancelled. And a b into minus b gives you a minus b square. So again, a very famous identity, and do not worry about this. We will look at identities again separately and then look at further applications, but all the same thing over and over again, and these are our fundamental operations. In fact, if you figure out the basics and they're clean, then this can be a very super fun meditative experience. You know what to do, you just have to open it up and write it neatly, right? It doesn't matter what this symbol represents as such. So this p square minus c square I can write as p plus c into p minus c. And I hope you are concentrating. P is not really p. What is p? P was a minus b. So instead of this, I will write a minus b plus c. Instead of write again, I will write a minus b and a minus c. So this and this are the same thing. Right? Please make sure that you're working all of this out for yourself as well. And each time you're repeating these identities and the basic operation. And this is for making sure that we are comfortable with this warmed up idea of algebra and nothing is unfamiliar to you, right? Because the other topics we can address without kind of going into this much detail for such a basic idea. But just to be very sure, right? And have that momentum and confidence as well as we hit later topics. So I hope this is worked out. Let's try the next one. M raised to 4 minus 256. So the first step that I can take is, can I rewrite this as m square raised to 2 and rewrite this as 16 square. So now notice basic indices are also coming into the picture. So investments made in number system, the basic indices, basic properties of how to multiply and rewrite things will definitely be helpful. So always remember, topics are interconnected to each other. Nothing is a standalone universe, right? So now again, the moment I write it like this, I do have, now this has become p for me and this has become q for me. So this is nothing but p square minus q square. That's how my brain is looking at it now. P square minus q square is p plus q into p minus q. So p plus q, instead of p I have a m square, instead of a q I have a 16, so m square plus 16, and instead of a p minus q, and then for p minus q I know p is a m square and q is a 6, and q is equal to 16, so m square minus 16. I can't do much with this, but this is again very similar because this is m square and instead of 16 I can write a 4 square. So m square minus 4 square, which I know is nothing but m minus 4 into m plus 4, a plus b into a minus b. So this expression can be rewritten as in this form. I'm sure I can further play with this also. But again, this kind of a scenario, right? Okay, the power of 4 and a short expression looking like this, what does it mean? Again, is going to come over and over again in different scenarios as we move through the whole algebra journey. So just getting comfortable and familiar with these basic operations so that next time a slightly more complicated problem, you're ready for it because you're aware of these basic games as such, right? I think 12, 13, 14 were going to be reasonably easy, so I'm going to leave them up to you. 15 looks slightly more interesting. 3m square plus 9m plus 6. So, so I can start thinking of the product. It could be a 1 into 6 or a 2 into 3. But even more interesting is the coefficient of m square, which is 3. Now, when it was 4, I could have said 2 square is 4, right? But because this is not a perfect square, it means that the coefficient of m are different in different brackets. And I can create a 3 only by multiplying a 1 into 3. So I say, okay, m plus something, I do not know, is going to be positive only, and the other m is a 3m plus something. So this m into m, my 3m square is definitely sorted out. And now let's think about the 6. The 6 could be a 1 and a 6 or a 2 and a 3. So just build your story. Say if it is 1 and a 6, what is going to happen? You have a 3m square, which is fine. You have a m into 6, which is going to give you a 6m. And a 1 into 3m, which is going to give you a 3m. 6m and 3m is going to give you a 9m. Great. And 1 into 6 is going to give you a 6, which is also absolutely fine. What I really want to do is make a mistake, because remember, this is a software. Nothing that you do or make a mistake will cause a real explosion in the world, right? So I always want to try out one more step, one more direction. So what if I put a 2 and a 3? Let's see what happens then. So m into 3m, 3m square, not a problem. M into 3 will give me a 3m, which is fine so far. So let's try this out. M into 3m will give me a 3m square, which is absolutely fine. M into 3 will give me a 3m. 2 into 3m will give me a 6m. So 3m plus 6m, again I'm getting a 9m. So absolutely fine. And 2 into 3 will give me a 6, which is absolutely okay as well. Wow, I wanted to make a mistake, but what I learned was that both are absolutely okay. Wow, I am pleasantly surprised, but I hope the basic game is more interesting. That how do I factorize it? Some hints are hidden in the number, and then I try it out. I multiply. If it doesn't work out, then I take an alternate pathway, which is the fundamental of our mathematical scientific thinking as such, right? Let's try 18, 25m square plus 30m plus 9. So this 9 looks like a 3 into 3, and this 25 definitely tells me it's a 5m square, right? So it is going to be 5m plus something and another 5m plus something. So now the only question is, what multiples do you want to try? 3 into 3 looks good to me. Let me try that out. 5m plus 3 into 5m plus 3. So 5 into 5m will give me a 25m square. This will give me a 15m, this will give me a 15m, giving me a total of 30m, and then 3 into 3 will give me a 9. Just to try and make a mistake, what if I change it to 1 and 9? So 5m into 5m gives me a 25m square, which is fine. But now 5m into 9 gives me a 45m, and 1 into 5m gives me a 5m, a total of 50m. So that's why 1 and 9 is not going to work for me, and I have great relief, because I really want to emphasize the method of making mistakes. But as long as our logic engine is running with the problem, we can always figure out and adjust our path, right? So plugging in the value, trying out, half knowing the structure, half playing with it would be the game. Just a different looking one, 49y square plus 84yz plus 36z square. Okay, so it looks different, but the basic idea is still going to be the same. First of all, 49 is a perfect square. So 49y square must have come from a 7y into a 7y. So my brackets are incomplete, but I can see 7y into 7y, definitely part of the story. And I want a z square, and there is a 36 here. So again, 36 could be 1 into 36, 36 could be 2 into 18, 36 could be 6 into 6. And not only just 1 into 36, 1z into 36z will give you a 36z square, right? 2z into an 18z will give you a 36z square. So I have that engine going on. What else do I know? I know this is the product involved. The sum gets played here, but the sum is getting multiplied by 7. Remember the original story that we worked with, that what if there is a coefficient that shows up in the middle term. So this 84 divided by 7 gives me a 12. That means the sum of these two terms is going to be 12. And that tells me, okay, it is going to be 6z and 6z only. And again, just put the numbers here and you will see it after you multiply. In case you're feeling confused right now, multiply this and you will see you have reached here. And then pause and rewind and think about what I'm saying in terms of how to figure it out. So I said, okay, I saw an example earlier, hit pause, rewind maybe 15-20 minutes back, where I was playing with the coefficient of x and I was thinking how it influences the middle term. So it was very easy. The new middle term was sum of the constants as well as multiplied with the coefficient of x or y in this case as such, right? So maybe pause and rewind and look for that story and you will see what I'm talking about. Or just trial and experimentation will give you that idea as well. Why am I dividing this by 7? Because I know that 7 also got multiplied to the sum. So I hope, I think I'm over explaining it. I think the idea would be clear by now. And of course, it is not always drop me a message and then I will know that, okay, it requires further work. A couple of more examples often sorts out the issue as such, right? Let's try one more just for confidence building, because 121 b square minus 88 bc plus 16 c square. So this 121 tells me 11b. So 11b, bracket close, bracket open, 11b, and then something else. There is a plus here and a minus here. That means both the terms are negative, because a negative and a negative will give you a positive definitely. This is 16c square, so it is going to be 4 into 4, 1 into 16, 2 into 8, something like that, right? And this is 88, but I know this 88 is after getting multiplied by 11. So 88 divided by 11 gives me 8. That means that original sum that we started off this whole journey with is going to be 8. And the product is 16. So 4 into 4, the product is 16, and 4 plus 4, the sum is 8. And there is a c here. So I will say 11b minus 4c and 11b minus 4c, which is nothing but 11b minus 4c whole square, right? So again, some of you still might be uncomfortable with this. In case you are that person, please multiply. Never ever give up. Always say, okay, one more break, one chai ka chuski, and I'll be back at trying to understand what's going on. And then multiply this and you will see what the game is. Or start with this story and go here, so that next time this kind of a situation will not trouble you, right? So I hope this made sense. Right, so I'm going to stop right now and leave the rest of the questions for you to work out, put some load on your brain. Most of the types I have already covered as such, right? So factorization, day 0, day 1, not even day 1, day 0 level of practice and work is worship methods. Now in later sessions, we'll again look at identities and maybe more complex applications or exam kind of questions related to identities. And then we'll move to the factorization theorem and the remainder theorem. Sounds complicated, but you will see it will still deal with these factors only. And right now we're just looking at the expression. If I make it and say if I make it equal to 0, then what is the value of b? At what value of b does this expression become 0? That is known as the root of the solution as such. So a lot of layers will come, but a fundamental operation for a long while will remain this factorization or multiplication, or basically being very, very comfortable with this. So I stop right now. Make sure that you try out the questions by yourself, especially if you're struggling with the topic. More practice at an easy level is required. And then in the next journey, we'll just pick off. And then in the next video, we'll just pick up from where we are stopping right now. We'll again look at an expression like this, equated to 0, think about roots, draw the graphs, everything that we have seen already. It'll just keep escalating in maybe a little bit of difficulty as such. So this is it for the day. I will see you really soon with the next topic.